not the usual sine function. So the function which is given over here in the integral is actually small si function, which is defined as integral from x to infinity with sine x by x dx. And also here's negative sign, because only if we give the negative sign over here while differentiating the above function, we get back the original integrand, that is sine x by x. Yes, so that's why we give that negative. Yeah, and something is wrong over here, because I cannot use the same variable over here as well. This should be t sine t by t dt. Yes. Now let's go to solve this integral. Obviously, the first thing to simplify this integral would be integration by parts, so that this gets differentiated to some normal trigonometric and inverse functions. Yeah, let's do that. So this is our u si of x, cos ax is our b. So integral of cos ax is sine ax by a minus, and then integral from 0 to infinity, derivative of sx is sine x by x, and then its integral will be sine x by a dx. Yes. Now this is from 0 to infinity. At infinity, sx function is 0. The other is between 0 and 1. So between 0 and 1, I mean between minus 1 and 1, and into 0 is just 0. And then minus it again 0. This is minus pi by 2, but this is 0, so again 0. Yes. And minus 1 by a, integral from 0 to infinity sine x by x dx. Yes. Now there are two ways we can simplify this. Yeah, basically first of all, let us take this integral only. Integral from 0 to infinity sine x by x dx. Yes. Now if we take this integral as, let's say, I of a, and then try to differentiate with respect to a, the x and denominator gets cancelled out. And we have something like this: sine x and then cos ax. Yes. But after this step, we'll again get into trouble, because after this we can use let's say product to sum of trigonometric function. After that, when we are integrating, this limits says infinity, will make the calculation difficult, and we will not be really able to evaluate those functions. So this approach clearly fails. So successful approach can be something like this. What we can do is, we can define I of t as integral from 0 to infinity e to the power minus tx, and then sine x, and then sine of ax by x dx. Yeah, we can define it like this. And then now we can differentiate with respect to t. If we differentiate with respect to t, we will get negative sign, integral from 0 to infinity e to the power minus tx times x, and the x cancels out. So e to the power minus tx sine x sine of ax dx. And now if we change this product to sum, then we will not get into trouble, because we can use Laplace transform. Basically this is in the form of Laplace transform, which we can do for some trigonometric function like sine and cos. So now we will not be in trouble, and let's see how we can proceed. Okay. And at last, after we found the answer, if I just evaluate, if I just put t equals to 0 over here, 0, then this will just be the required integral over here, so there's no need to worry about that. Yes, yes. And now, okay, yeah. So basically, if when I put 0, this is same as the integral over here. Now, um, let us convert this product to sum. Yes, basically cos of a minus 1x minus cos of a plus 1x. Yeah, and next thing is to use Laplace transform. Now here the variable of the complex domain is t. Yeah, the other world is t, and initially we are in x. So if we use the Laplace transform, we know that for cos 8x, Laplace transform is basically s by a square plus s square. So using similar formula over here, we get t by t square plus a minus 1 whole square. And something I forgot is that basically while taking into the sum or difference, we will also have a minus 2 over here. We will also have a by 2 over here. Yes, I forgot that. So also 1 by 2 should be here. And then minus t by t square plus a plus 1 whole square. I'm sorry for this. Yeah, a square. Okay, now we have the answer. Now I have to find I of t. So basically I'll just integrate with this respect to t. So basically we can take 2 in denominator and 2t and 2t over here. Now if we take this whole expression denominator as, let's say, y, dy will just be 2t. Yeah, so this is basically dy by y kind of thing, which is the derivative of log function. So from there we can see that this is actually equals to 1 by 4 ln of this one is basically t square plus a minus 1 whole square by t square plus a plus 1 whole square. Okay, we got this, but we don't really need I of t, we just need I of 0, because this term needs to vanish so that the other expression is what we want over here. So let's try to find I of 0. I of 0 is minus 1 by 4 ln of a minus 1 whole square by a plus 1 whole square. Now this whole square is the basically the square of the entire thing over here, so the square can be taken outside, and we get I of 0 is equals to minus 1 by 2 ln of a minus 1 by a plus 1. Yes, now this is the I of 0. Yeah, and what's the next thing that we need to do? That is to replace this value. This is of the integral sine x by x. Yeah, so replace that value, and we get minus 1 by a times minus 1 by 2 ln of a minus 1 by a plus 1. Yes, so we get 1 by 2a ln of a minus 1 by a plus 1, and this is the answer of this integral. Yeah, so we have solved this, and to talk about the flow of the problem, we first use integration by parts to simplify the SI function, and then we saw that like to dismiss the action denominator, directly differentiating won't work, and we have to introduce a new let's say term e to the power minus tx, and from there we can differentiate to vanish x, as well as later on we can simplify using Laplace transform, and that worked quite well, and then finally we got the answer. So that was it. Hope you enjoyed the video. Thanks for watching, and look forward to seeing you in the upcoming videos too.